discussion on will HVAC and lighting work together for better occupancy data and energy savings? I'm Ron Bernstein. I'm with RBCG Consulting, and I'm working with the team at the Design Lights Consortium in helping develop this path of integration between the lighting industry and the HVAC mechanical industry for better optimization and energy. And you're going to hear a lot of information about that today. So we're very excited to have our presenters. Oh, wait. All right, so we have a nice panel today of industry experts. Let me introduce them. I'm going to introduce them once, not every time here. But first we have Levin Knock. Levin is with the Design Lights Consortium. What is your official title?
Senior Technical Manager.
Senior Technical Manager, and he's been one of the leads working on this HVAC to NLC, and you're going to learn what NLC is today, Network Lighting Control. Levin's been leading this project and with support, and I'll also mention Stuart, who's not speaking, but Stuart is here from the Design Lights Consortium. Raise your hand, Stuart. I caught him with his mouth full. He's been busy. So we also have Carol Jones sitting right up front here. Carol is with the Dolly Alliance. How many folks are familiar with the Dolly Alliance? Okay, you're going to learn more today. So, just about a half dozen or so. So you've got some newbies for you. And then we have Simon Slupik. Am I pronouncing Slupik? Simon is with the Bluetooth Alliance for lighting, and he's going to talk about how Bluetooth and the lighting market are advancing interoperability and new standards. And then we have Matthew Turk. Matthew is sitting here in the front row from Newcomb and Boyd. Matthew is a consulting engineer that designs systems around connected buildings and what we call Div 25 integrated automation. So that rounds up the panel today. We're going to start with Levin. Let me bring up our agenda. So there we go. So we're going to switch between folks. We're going to have a broad overview that Levin is going to frame for you about today's session, about this toolkit, which we'll talk quite a bit about. I will mention that on that flyer that I handed out, and if you didn't get a flyer, the handout, on that handout on the backside is an overview of the toolkit, and then one of the QR codes on there is where you can go to the DLC website and download that toolkit, and that's to help specify these integrated lighting and HVAC systems. So that's the scope of today's panel. With that, let's bring up Levin. And Levin, please take it away.
Thanks, Ron. The DLC, or Design Lights Consortium, is a nonprofit organization that promotes high-quality, energy-efficient commercial lighting products for non-residential buildings in collaboration with utility energy efficiency programs, lighting manufacturers, and other stakeholders. Lighting products on our list are eligible for rebates and incentives to save energy across much of the U.S. and Canada. Since 2010, we've played a central role in the LED revolution in non-residential buildings that has saved a bunch of electricity. To give you a sense of what we do at the DLC, I want to tell you about contra dancing, which I used to enjoy when my knees were younger. Contra dance is a bit like square dance, except instead of forming squares, the dancers form long lines across a dance hall with dancers facing each other. Dances involve a series of standardized dance moves where a caller yells out each move to do next, and everybody does that dance move. When all goes well, you can have a great big room full of people moving around quite vigorously without anybody crashing into anybody else. This is possible because everyone agrees more or less on what is a do-si-do or a allemande, and everyone agrees on which is your right hand and which is your left. When people in different lines all agree on these standardized motions, then dances flow smoothly and they're a lot of fun. Which brings us to the DLC. The main thing we've done over the past 10 years is to provide tools for collaboration so our member efficiency programs and industry partners can move in coordination more smoothly. The DLC works with efficiency incentive programs to agree on a common set of DLC requirements so lighting manufacturers can meet one set of requirements and then qualify for incentives from many different programs. We succeed at this by listening carefully to each side and updating our requirements accordingly to support collaboration between these two groups. Now, we're exploring ways to help the industry silos of lighting and HVAC work together more smoothly. And here's why. For the past decade, LED lighting retrofits in commercial buildings have delivered affordable and reliable energy savings for electric utilities and for building owners. But now, with efficient LEDs already installed in many buildings, utility programs need new sources of energy savings. Network lighting controls, or NLC, could help, but they often seem expensive compared to the relatively small amount of energy they can save when the only load they control is LED lights. Still, when network lighting controls do manage to make it past value engineering and get installed on a project, they provide powered, networked occupancy sensors everywhere throughout a space. In suitable buildings, signals from those occupancy sensors can inform the HVAC controls to relax the temperature set points by a few degrees in all unoccupied areas. Some buildings can also reduce the ventilation rate for additional energy savings. As you probably know, this is called occupied standby mode. It depends on occupancy sensors that might or might not be part of a network lighting control system. Today's commercial buildings use more than half of their energy for HVAC and about 10% for lighting. The total combined savings from new LED lights with network lighting controls integrated with HVAC for occupancy standby mode can be over 20% of the whole building load. Substantial energy savings like that from NLC HVAC integration can be your key to helping building owners unlock rebate incentives and lower utility bills by taking a step beyond common practice. Energy savings from systems integration can be attractive to building owners, especially for people with buildings larger than 50,000 square feet that already have a building automation system and may even be subject to building energy performance standards. Occupied standby mode is also feasible in some smaller buildings, usually with old-fashioned analog dry contact technology. But soon, thermostats with Wi-Fi or Bluetooth connections will support plug-and-play digital versions of occupied standby mode in smaller commercial buildings without full-blown building automation systems. Building automation to coordinate different building systems is the wave of the future. Integrating lighting controls with HVAC controls is a good place to practice building automation to apply in the future across more building systems. Those are some of the reasons why lighting HVAC integration is worth pursuing. However, it rarely happens today. So the DLC has been working on ways to help it happen more often. Before I show you the DLC's new freely available integration toolkit, I need to take a minute for a few definitions. The term network lighting control can mean different things to different people. For the DLC, it means a combination of sensors, network interfaces, and controllers that effect lighting changes in luminaires, retrofit kits, or lamps. These devices may communicate with each other using a wired protocol, such as DALI 2, or a wireless protocol, such as Bluetooth NLC. When sensors for occupancy control and daylight harvest are on board every fixture, that's called luminaire level lighting control, or LLLC. That's good for spaces of all sizes and especially good for smaller buildings. I'm treating LLLC as one kind of network lighting control, or subset. Some network lighting control systems are connected to the internet, while some are not. Others have an occasional internet connection over the operator's mobile device. That concludes the definitions. So now we'll explore the result of 2 years of work at the DLC under the guidance of researchers and advisors from both the HVAC and the lighting industries, which is a new toolkit to support NLC HVAC integration. The toolkit can be downloaded for free at the designlights.org webpage for NLC HVAC integration. You can find that webpage using this QR code that is on your handout, and we'll also show it later during the questions. The Toolkit will help you choose appropriate projects for integration that are likely to save energy at a reasonable price. They will help everyone on an integration project work together more effectively, and they will help your team create successful projects that save energy by providing lighting, thermal comfort, and ventilation only when and where they are needed. My goal in this presentation is to introduce the Toolkit to you so you'll know what's in it in case you ever want to use it. And second, to ask for your feedback in the Q&A session later and also anytime afterwards. If you want to share your experience using the Toolkit, or you see ways that DLC could improve future editions. The Toolkit contains 5 different files bundled up in a zip file. First is the handbook, a concise reference manual. Next is the decision tree, a guide to help you choose appropriate projects for NLC HVAC controls integration and to avoid projects where success is unlikely. Next, there's a spreadsheet list of case studies of 18 integration projects so you can read about projects like yours, including lessons learned. Files 4 and 5 document an example project and can be edited to apply to your own project. The responsibility matrix describes major tasks and participants, showing who is responsible for what, and the project template is an example construction integration specification aligned with CSI Division 25 on integrated automation. Next, we'll look at some of these documents in more detail. The handbook is a concise reference manual with the different sections shown in this table of contents. The definitions include a few pages of essential terminology, and standards listed in the references at the end define many additional terms that might be new to some readers. The goal is to help everybody on an integration project understand a little about what the other people are doing. For instance, people experienced in lighting controls will already know most of what's in the NLC section. But if they read a few pages about building automation and management systems, they might be able to collaborate better with folks working on those systems, and vice versa. The best practices section has standardized recommended best practices for everybody, and including how to write a good sequence of operations in the world of lighting and also in the worlds of HVAC and building automation. The decision tree diagram has 7 topics to consider when deciding whether to pursue NLC HVAC integration on a particular project. This one-page diagram is sufficient by itself to eliminate some projects from further consideration. If a project might have potential at first glance, and you want to consider it more carefully, each topic in the diagram has a corresponding page in the PDF file with a number and a color for that topic. You can click on a topic number in the diagram to navigate to the page about that particular topic. Next is a list of case studies of NLC HVAC integration projects. This zoomed out view shows all the data in the Excel file. Each row describes one of the 18 case studies, and each column addresses one topic. The data can be easily filtered based on any of the topic headings. Most of the projects are retrofits, but a few are new construction or major renovation. Here's a list of all 22 column headings. You don't need to read them all here because I'm going to go through them in the next 3 slides. The first 9 topics are all pretty short, as shown here, such as building type, location, square footage, building characteristics, and which systems were integrated. The next 4 columns have more extensive text, with a summary of each project, a description of the project objectives that drove the decision for integration, a list of lessons learned, and an overview of the control strategies that were used in each project. And then there are columns about the HVAC system type and schedule, energy saved, payback, incentives, date, and the source website where you can find the full original published case study. You can see that some of the cells are empty because some case studies did not address every topic. The 18 projects include these 7 different types of building, so you can see how some of the control strategies and integration objectives varied by building type. We aim to make the list larger as we find more case studies that are suitable. There are also 2 templates in the toolkit that you can edit to help manage who's doing what on an integration project. A responsibility matrix in Excel linking people with tasks, and a CSI Division 25 contract excerpt for integrated automation to specify what needs to be done. That concludes our tour of the main features of the new DLC NLC HVAC integration toolkit. Please try it out, and if you do try it out, I would love to hear about your experience with it in terms of what works and what could be improved. As I mentioned, the integration handbook includes an introduction to network lighting controls. At the end of that section, page 16 describes resources for further exploration. One of those resources is a list maintained by the DLC of different network lighting control systems. I'll show you where to find the list and what information you'll find on it. Our network lighting control system technical requirements serve as a filter for our list to identify systems that are eligible for efficiency rebates and incentives. This helps lighting control manufacturers design for a single specification rather than meeting different specs from dozens of different efficiency programs. In the DLC technical requirements, some system capabilities are required that every system must offer to be on the list. Additional optional capabilities are reported, which means that some systems have those capabilities and other DLC qualified systems do not. All NLC systems on the DLC list can support the required capabilities shown here. For integration projects with HVAC systems, the most relevant are the top 3: networking, occupancy sensing, and cybersecurity. Some systems also support optional reported control features. The main ones that are relevant to integration are remote diagnostics and external systems integration. Now I'll show you some of the data that's available in case you help choose an NLC system or you need to integrate with one. At the designlights.org website, you can create a free user account and then log in to see this dashboard. Choose Find Products to see a choice of our different qualified products lists, or QPLs, for LED lights, horticultural lights, and network lighting controls. Choose the NLC QPL to see this online list of 90 network lighting control systems. You can use the filters on the left to narrow down the selection in various ways, such as by manufacturer, brand, and the scope of whether it covers indoors or outdoors. When you open the Advanced Capabilities filter, you can filter by things such as integration with BACnet systems. If you check the filter box for integration with BACnet systems, that narrows down the list from 90 systems to 31 systems. Now suppose I want to see more details about one of those 31 systems that supports BACnet integration. I can click on a product name to see a pop-up window with information about all 22 required plus reported capabilities for that one product. Each product supports all capabilities shown with green check marks, but not the one with red X's. For any capabilities with a green check mark, you can select it to see more details in one of the 7 gray windows that open below the summary section. For instance, if I select the external systems integration capability, and then the interoperability window expands. We've got a lot of data on interoperability, so I need to scroll down to get to the section on external systems integration. Here I've scrolled down to External Systems Integration section, where you can see various data fields, including a list of communication protocols, which for this product has one thing on the list, which is BACnet IP. Here's a similar view of the interoperability window from a different NLC product that supports multiple communication protocols, including BACnet, contact closure, Modbus, etc. Also, this system chose to report some of the data that's available for the BMS, such as the occupancy status at the luminaire level. Moving on from the interoperability window to additional capabilities, you find similar details on other topics such as cybersecurity and remote diagnostics. Leaving the product-specific data window, we're back in the main view of all 31 products that support BACnet. If you want a spreadsheet of all the detailed data to compare multiple systems, you can make a list of all the systems you're interested in and then download all the data for your product list to an Excel spreadsheet with a row for each NLC system on your list and a group of columns for each of these 22 capabilities that DLC collects data on, for a total of more than 120 columns of data. So whether you're choosing an NLC system or integrating with one that somebody else chose, the DLC qualified product list can give you a lot of information about your NLC system. To recap, the DLC has published a Toolkit collection of 5 documents that is freely available for you to use on projects to integrate network lighting controls with HVAC controls. These documents point to several additional resources, one of which is the DLC list of network lighting control systems. This toolkit will help you choose appropriate projects, will help everyone on the project work together more effectively, and will help your team create successful integration projects that save energy. Next, we'll hear from Ron and later Matt about the toolkit value from an integrator's perspective, and also from Carol and Simon about recent developments in 2 powerful digital standards that can make lighting systems much easier to integrate with compared to the old analog systems.
Oh, no, that's me. All right, super. Thank you for that great introduction. I appreciate that, Levin. How many folks in the room have ever heard about the Design Lights Consortium? Did we do that yet? So less than half. Okay, so a lot of new people to this. Great set of resources. So I want to talk a little bit about what we've learned over the last period of time since we've been working on this and collaborating and trying to bring this concept of a network lighting, let's call it infrastructure, into the bigger building automation and controls market. Early on in the first round of research that we did, we were looking at the opportunities for the lighting market to broaden its, let's say, footprint beyond just reducing the energy cost by moving from fluorescence or incandescence to LED, which is the big low-hanging fruit. When that's done, the energy alone of lighting has a minimal level of gain, a step gain from where we were with incandescence. But what we have learned is that the lighting infrastructure offers us a tremendous opportunity to utilize the more pervasiveness of the lighting system for adding sensors. Now, the most obvious one is an occupancy sensor. But if you look at where lighting systems are in this room versus where our HVAC interface for this room is, there's maybe 100 to 1. So if we start looking at where we can add value, I'm a believer that the lighting system offers a tremendous opportunity for advanced sensors such as humidity, potentially sound and sound masking, gunshot detection, if those are familiar with that, advanced air quality sensors as well. So we started looking at where these two things might work, and the most obvious one started off with an HVAC occupancy and lighting occupancy working together in a common sequence of operation. So we held the summit, the DLC held the summit last year, and at that summit we presented these concepts, and probably the most important thing we took out of it was that people aren't asking for integration, they're asking for these positive outcomes and efficiency and systems working together, which we all took to mean we need better integration, meaning that we need to be able to share data. So there's some very good opportunities here. So we started looking at, well, how can we move to a smarter system? If we talk about the general smart system from specific, measurable, actionable, reliable, and timely systems of a smart building system, we hear a lot at this show about how we make smarter buildings? Well, the bottom line of that is communication. It's the ability to share information in an open, interoperable, understandable way. BACnet has done a great job with that. Other technologies are also in that world of standardization of information so that they can be non-siloed and cross-discipline. So the ability to consume and produce data or information is another aspect, and the ability to act and respond to change. And I like using, hang on, get my mouse back over here. I like using this diagram that says data starts with signals. The data of an occupancy starts with that passive infrared sensor saying, contact closure, we've got somebody in the room. And then we add information and context and the actionable information on that to get up to this level of wisdom and being able to do something with it and repeatably being able to do something. So as we increase our data set context, we get greater value of that data. Well, part of the effort that we're working on here in the DLC is to make that data more applicable to an overall building automation project and also define it in the way of the smart buildings world. So here's a kind of my definition of a smart building that enhances the performance, increases the ease in operation, improves the cost and the facility ownership level. It's a higher performing environment where we don't have single, standalone siloed systems. We have more integrated systems. They are operationally more advanced. We can see more information. We can take action on them. We can do greater fault detection and diagnostics, more predictive maintenance, and we offer greater comfort and satisfaction. So a few others on there. That's sort of my broad definition of a smart building. But when we're talking about this project, we're really looking at the operational efficiency and also the energy efficiency. Now, one of the things that Levin didn't talk a lot about was utility incentives for doing this. So that's another area of research and of opportunity, that there are utility incentive programs that are focusing on connected lighting and HVAC systems to offer energy rebates as part of an integration project. So when we think about HVAC, yes, there are some rebates for HVAC, but not all integrators are thinking about, hey, if I integrate my HVAC and my lighting, there's additional utility incentives that we can go after. So that's something that we ought to be considering. As we're moving to electrification and decarbonization, which if you've been to any of the sessions between ASHRAE and AHR, you've heard those terms. Those terms are pervasive in our industry now. We're moving towards more demand on the electric side, more heat pumps, with lighting systems being, again, very focused on the energy efficiency and the operational efficiency. We start getting these project goals that overlap. And when we do those overlapping goals, we also have to take into consideration the cybersecurity. So that's a whole nother topic we won't spend a lot of time on today. There's actually a session going on right next door on cybersecurity and zero trust of building automation systems starting right after this one. So we want to make sure that the data that we're getting in the toolkit, there is some discussion about what information comes out of the NLC, the network lighting control system, that's useful for the HVAC system. So as we extend those systems and converge those systems, that overlapping information can help the system designer, which Matthew over here is going to talk a little bit about, as to the value of using that information in a more concise and operationally efficient way with the sequences. So we get greater value, better decision, and better modeling of our buildings. So as we look at some of the objectives of a framework around connected systems, we have our objectives, we have our components, and we have the teams. All of these three things have to sort of work together. So I won't spend a lot of time on that, but the idea here is that it's not just the designer, it's not just the specifier, it is also the vendor, the solution provider, the integrator, and it all starts with the owner. The owner saying this is important to us. So when we design a spec, there are lots of things that go into our system specification. It's not just, hey, make these two things work together. Are there any specifiers in the room other than Matthew? Okay, so we've got 2. All right, so you guys are really in the driver's seat of how this industry is going to work together, is writing a good specification. I include myself in there. And one of the challenges that we have, if you get down to the brass tacks, is if we have a building, what does that building's lighting zones look like versus what do the HVAC zones look like? And is there overlap in the design so that we can use the lighting occupancy sensor or sensors in a space to effectively change how we operate and control the HVAC system? So we have to have some harmony in the design there. That shouldn't be designed in silos. We ought to be thinking about, how many sensors are there in the room? Which ones would affect which air handlers? How do they overlap? And what data can we get out of those? And how do we maybe use that for our sequence of operations? So there's the start with this toolkit from the DLC will have great advantage to the lighting market influencing HVAC. And I think the HVAC industry will learn a lot from the lighting industry about how to work better together. Part of all of this is ensuring we have one unified system, that things work with each other. Well, that doesn't necessarily happen unless you have what I refer to as both the CapEx team and the OpEx team working together. Because oftentimes if you do a siloed project with just HVAC and mechanical in one bucket and electrical and lighting in another bucket, and they never talk with each other, and they're not working with the operator, it's part of the operational budget, you're not going to get that harmonization benefit. And also thinking about the ongoing incentives, utility incentives for energy reduction, all of that has to play together in a harmonized environment. So we want to maximize the efficiencies and outcome by looking at both sides of the coin and try and reduce that finger pointing. Says, hey, my system doesn't work because your data doesn't work, or I'm not getting your data in the correct way. We try and reduce that through standards. And we've now introduced, just the last 2 days, I helped introduce these concepts to the ASHRAE Specifying Building Automation System project, which is Guideline 13, if you're familiar with that. So we're looking at enhancing the lighting section of that document to include some of these concepts. So I will stop there, and I'm going to invite Carol and her beeping coming, and your beeper. We'll take questions afterwards. We'll get through all the presentations. We'll get. Come on up.
Okay.
Thank you.
Sorry about that. Hello, everybody. So we're using the space bar, yeah. Okay. So the DALI Alliance is the organization that develops the specifications, which are not called specs, they're called parts. And the way that it works is that the group, the technical committees get together and they develop spec language in a consensus process, which then gets published by DALI as a new or revised part. Importantly, once that's done, it gets adopted by the IEC 62386. I'm going to get my glasses because it's important. And what that means is that it's now a global standard. So, and DALI's been around for a very long time. DALI's been around for decades. It's 20 plus years. And this process has been used for a long time, and the parts increase. There are more and more parts. It started as a very basic protocol, which is like the language of lighting. Consider it that, digital addressable lighting interface, right? So DALI is talking. And then over time, these parts have been developed, which actually describe how these different products work together. And so there's a long list of that I won't go into, but DALI version 1 came out, I don't remember which year, and that was everything functioning together but did not have a certification. And so what happened in this market is that the DALI 1 products that came out, because they weren't tested, there was too much variability in the implementation by the manufacturers, so there were issues. And that's sort of where the story ends in North America. What happened in the meantime is that DALI 2 came along, which included a certification. And so that certification was a game changer. Europe, Asia Pacific, others continued working with DALI, and here it got quiet. We're a gossipy bunch over here. And so not much happened. But importantly, that's a good thing to understand, is that DALI 2 was a fundamental change, because once you have testing and certification, now you can say these things are in fact interoperable, right? They wouldn't actually pass certification if that weren't the case. Once that's developed, there's a launch of the certification. People go through the process of certifying, and then they add their products to the database. There's a big database run by the DALI Alliance that contains all of the different products that are certified. For this conversation, what's important is D4I. And D4I, actually, I'm going to go to the next one first. Big picture, DALI is the umbrella brand. And as I described, DALI version 1 was the first thing that came out, and then followed by DALI 2. And so DALI 2 is wired. Actually, DALI 2 is sort of the introduction of everything else, which is a series of different things. But DALI 2 is wired for major renovation and new construction. And, oops, spacebar. D4I is actually an intraluminaire thing. It means everything is sitting inside of the luminaire as opposed to being extended elsewhere. So if you've got luminaires all in a row, you're going to have drivers that are in intermittent spaces, but they're not going to be one for one, right? So that's a very different thing from one for one with integrated sensors in each fixture. When it comes to integrating with HVAC, it's the D4I opportunity with the integrated sensors that gives you a chance to have these overlapping zones. And that's a relatively new thing. Some people have heard of the integrated sensors. Some people have never heard of the integrated sensors. But importantly, the standardization is a really big deal. And the latest thing is DALI Plus, which I won't get into, but it is native IP addresses, etc. So lighting control on or in luminaires, LLLC, I've started calling it triple LC, easier to say, includes the drivers, the sensors, the controllers connected by DALI inside of the luminaire. So that's the sort of basis for this. This is, okay, so here is, I won't get into the details of this, but here is a system architecture drawing of how it all works together. There's a bus that provides power, and various different things can come off the bus. So that's the basic. This here is about the intraluminaire. So you've got a network. You've got the DALI D4I luminaire. From there's an interface which has been developed by DALI. And part 341, remember I said spec is part, right? So part 341 was developed specifically to work as a communication between D4I, DALI D4I, and Bluetooth. And so that's a big part of why we're here today. There's also another one that communicates with Zigbee. And so when you have that, you've got the D4I, which is capturing data and driving the light, and sitting here, and the wireless communication is here. So D4I is not wireless in itself. It's sort of like a foundation of what's there, where the wireless communication and the lighting control happens from there. Really importantly, the whole point of DALI is the communication, right? So if we're here in North America, we'd say, okay, it speaks in English, right? It speaks lighting. And the second thing is that all of the different parts are specifications that are consistent one to the next. And so what that means is that you've got memory banks, and you have semantics and all of the things that are necessary in order to make this work, and it's consistent. So that means that whether it's D4I speaking to Bluetooth, or whether or not it's something sitting on top of the D4I to actually communicate beyond to platforms or whatever, anything that sits up above, is going to be consistent. So if you are a manufacturer, say building automation systems, when you are working with a DALI system, you can guarantee that the data banks and the technologies are going to be consistent. So once you figure that out, you don't have to figure it out again. And that's where the interoperability comes in, is that you've got this consistent way of communicating. So this picture is here to express to you that each of the addressable points can be grouped together in different ways. Zone is a different thing. Zone, think wires. Right? Groups are, I'm going to grab these over here and I'm going to make them do this, and I'm going to grab these over here and I'm going to make them do something different. And they can overlap or they can function independently. So you can capture fault diagnostics, you can do emergency testing remotely, you can do color control that's calibrated and consistent from one to the next as compared to 0 to 10 with 2 different drivers trying to match everything. And so that's an important thing. The addressability is important. If you go up to the next level, the addressability gives you all kinds of opportunities related to electrification, balancing the grid, et cetera, because you now have this way of communicating one for one. So let's say, for instance, if you're trying to reduce the load in a building and you know where these fixtures are, you've got something integrated with HVAC, you've got your HVAC zones, you've got your DALI groups through perhaps a wireless system, and then you can roll it up and say, how am I going to control individual fixtures in terms of balancing the load? And different spaces have different priorities in buildings, right? There's a workspace, there's a hallway, there's a, et cetera. So that way you can maximize how you use it. Okay. So that's that, and are you next? Yeah.
Good. Okay. Good afternoon. So next few slides are about Bluetooth NLC, Bluetooth Network Lighting Controls. That is a standard, the wireless standard, and how that enables integration with HVAC. So a few words about Bluetooth NLC itself. So this slide shows the evolution. So from left to right. It all started in 2010 with the introduction of Bluetooth Low Energy. It's the foundation, the radio technology that is the foundation of like almost every low power radio communications today. So we use it in phones, we use it in wearables, we use it in wayfinding beacons, we use it in computer accessories. And in 2017, the second block, Bluetooth Mesh, was introduced. So Mesh uses Bluetooth Low Energy as the underlying radio and then introduces the Mesh transport on top. And that's very important because initially Bluetooth LE only allowed for point-to-point communication, like a mouse to a computer. With Mesh, basically we have many-to-many, so we can have many sensors, we can have many light controllers. That's from this industry example, and it's very scalable. So it can go like many thousands of nodes in a single network. It's a very powerful property of Bluetooth Mesh, that it's really scale. Unlike the conventional wisdom about Bluetooth used to be that it's a small area communication, like small accessories, wearables, and so on. With Bluetooth Mesh, we can cover really full buildings or even full campuses of multiple buildings in a single network. Now, in 2023, which is a year and a few months ago, the final piece to the puzzle was introduced by Bluetooth SIG, which is called Bluetooth NLC. And that is the NLC device profiles. So that closed the loop towards the full cross-vendor interoperability, because now we have the full stack of specs which define the radio, the transport topology, and the device profiles. And the device profiles, there are 6. They are very intuitive. So we have occupancy sensor profile, ambient light sensor profile, energy monitor, dimming control, scene selector, and lightness controller. And basically those 6 enable, these are like pieces of a puzzle, and they enable to build any lighting control system out of those. So typically these 6 profiles 6 roles. And if you want to know more, please go to bluetooth.com/Bluetooth NLC. There's a full explanation and case studies and so on. And this has been super successful, if not the most successful wireless lighting standard in this industry. So based on the ABI research study, this is poised to grow to double every year looking forward. So this is really taking over many other standards and like because of, I would say, two aspects. One is the performance and scalability, and the other is really it delivers cross-vendor interoperability. So you can mix and match devices from different vendors in one system. They just work together. So now, where's the HVAC part? The HVAC part can be with Bluetooth NLC can be done in two ways. So large buildings typically and small buildings. So in large buildings, the assumption is that there is a building management system, and in the BMS world, typically BACnet is the reigning protocol. So of course, it is easy to imagine a gateway product which sits between the Bluetooth Mesh lighting network and the BACnet subsystem, and then that BACnet gateway simply provides data communication back and forth, but it really exposes the Bluetooth devices as BACnet objects. So on different levels. So you can have each individual sensor, occupancy sensor, Bluetooth Mesh occupancy sensor exposed as a BACnet object, but you can also have a Bluetooth occupancy zone as whole zone exposed as a BACnet object. So there's different levels of granularity possible. And then, of course, from the HVAC perspective, you can subscribe to those objects, use the change of value technique to be notified about the occupancy events, and then consume this data. So that's one way for buildings which have BMS systems. Now, as Levin mentioned, there is a huge market of smaller buildings which are fully analog. They don't have anything. They have copper wires, and that's what they have. And very often they have, of course, thermostats, but these thermostats are standalone. I mean, they are not connected to anything. They control room level or floor level, depending on the venue. And this is where the Bluetooth helping hand really comes handy, because the new specification, which has just been launched, a few more about this spec on the next slide, but this is the lower part of the slide's idea, that you have the meshed lights with LLC concept. Every light has an occupancy sensor. So the grid of the occupancy sensors is dense, and you have this high granularity. And then you have the thermostat, and the thermostat can simply subscribe wirelessly to this lighting information, because like the way Bluetooth NLC works, it works through publish subscribe paradigm. So every device in Bluetooth NLC mesh network publishes data. So that's the beauty of there's no point to point, there's no target destination address of the information, it's just publication. So each publication can be identified by a group address. That's a technical term from Bluetooth NLC, group address that represents the function in a given space. So the function in a space is occupancy, sensors published to that address, and then the thermostat can simply subscribe to that address. It's quite similar to what we do on social networks, that we publish using a hashtag, and then anyone else can subscribe using the same hashtag, and then that's how the match is done. So really the powerful thing is that the sensors do not target any specific device. They just publish the information which can be identified through the hashtags. The HVAC integration NLC profile. This is the latest addition to the group of Bluetooth Mesh, Bluetooth NLC profiles, the 7th one. And actually that was published last Friday. So it's a just-in-time action, I would say, from Bluetooth SIG. The spec is still in the draft form. So this is, technically speaking, 09 version of the spec. Technically, it's complete. So basically, people can start building their devices today. The thermostat companies can use that spec to start building their prototype thermostat products using or being able to subscribe to occupancy sensors. It will take few weeks for the spec to mature. It is now in so-called member review period. After that, this spring, it will be adopted officially by the Bluetooth Board of Directors, which will enable certification and qualification, which is also important because the part of like the DALI Alliance, Bluetooth SIG does the same. It does very thorough testing of end products to ensure the interoperability really happening. So I invite everyone to look for that spec. There's no link here, but if you simply use your default search engine and search for the HVAC integration Bluetooth NFC profile, then you'll find it easily. It's available to everyone today. So with that, I would invite now Matt to take over. Thank you.
Thanks, Simon. Matt Turk here, Newcomb & Boyd. Thanks for the introduction, Ron. So I'm going to kind of quickly try to summarize what we've been going over here today. Right, so at the very beginning, what this tool set can help you do is if you're an owner and you want to set your design vision or you want to have a standard, there's information in here for you. Or if you're a design consultant, and there's information that can help you potentially in this tool set, right? Now, I do a design. Like I'm a designer. I'm designing consulting. I do this every day of the week. This is what I do for multiple systems across various platforms. It's going to help you if you need to select pieces of equipment, understanding what to select and how to select it, right? You're also going to have a better understanding of how you're going to have to deploy your network potentially, whether that's a wireless network, whether that's a wired network. And then if you're going to deploy a network, how are you going to secure your network and how are you going to secure the devices on your network? There's information here which can help you potentially with that, which is great. So if you're working on the delivery side, hey, I know I'm going to need to plug this thing in somewhere. And I also am going to know like this is what I need to adjust on my device so that I'm going to comply with my owner's standard. I'm going to put a password on it. I'm going to make this password to a certain standard and we're all going to be good. And I'm going to specify that that's going to happen because the owner told me they want a directive to do it, right? Finally, I'm going to have standards that are going to be developed so that I can properly configure my system. I got to perform a sequence of operations, and I need to document it too. If we're going to share data between systems, there has to be a correspondence to the physical reality above us in a building. Something may mean like a set of numbers and a bunch of data, but that doesn't necessarily mean it corresponds to actual physical location, which is why the documentation section right now is so important. Hopefully, more systems will self-document in the future, but most of them don't do a good job of doing a geopositional type of documentation. Finally, we're going to need to commission our system. So if you've seen traditional delivery of HVAC or lighting, you traditionally have a commissioning agent. They're going to come out. They're going to check it. They're going to make sure it functions right. Well, what happens when then you need to do an integration? If you're sharing data between the various systems, you can have that system programmed and finished potentially, but you haven't necessarily programmed the other system, which is going to consume the data outside of it. So what's going to happen with that? Well, what you can do with this framework is you can help define the activities that need to happen for that integration to occur, right? And then finally, we're going to get to a new step that's going to have to happen on all the projects. How are you going to do this? Are you going to validate that you have the integrated commissioning? Are the sequences set so that they can be formed properly, right? And then if we do all that correctly, we'll get a building and everybody's going to be happy because we're going to get the experience the owner wanted when they defined their standards or their owner programming requirements at the very beginning. And everybody walks off the project and everybody's happy. And that's what the best part of it is. Now you also see kind of on the left side here, there's some potential options for some new roles you may run into. You may see a master system designer. Traditional MEPs delivered in buckets and silos, the same way the traditional verticals you're used to. Plumbing is plumbing, HVAC's HVAC, lighting, Division 26, plumbing, Division 22, HVAC, Division 23. You have silos. You're going to have someone who can go in between those silos and bring it together for you on the design side. That's what I do a little bit. And then you can almost think of that master system designer as your architect for your systems, and how the systems are going to go. Then you're going to have your typical systems integrator. If you work in HVAC, you have a vertical there. Maybe you want to evolve and you want to become a master systems integrator where you can do multiple systems. Or maybe you want to say, hey, this is my silo, I'm going to stay on it, but I'm going to know who I can work with in the industry who can actually perform this role for me. That'll be great too, right? And then I finally got to get into commissioning. Like, there's also a lot more variety we can do here now with more data. If we do a good job of this integration, we can actually have this integrated commissioning be more of a process where you validate the data itself, and you don't have to go on site anymore. Instead, you can do that remotely with algorithm, with AI potentially in the future, or for now, just with someone who actually understands how the building's been intended to perform, right? So there's a little bit more here. Here's this example of what some documentation might look like if you're receiving something from me, right? So we had this responsibility matrix we talked about. That should be a part of your documentation. You might see something like the top left-hand corner. These are the system points that need to be shared. I'm going to establish what that is and let you know how you're going to get about doing that. And then finally, you kind of have a somewhat of a network topology. How is this actually going to go together as like an architecture? All of these are key elements to making sure this happens. And there's information in this DLC toolset to help you get started on this road and make that possible. And with that, I'll hand it back over to Ron.
Okay, I want to say thank you to all of our speakers. Everybody did a great job. Let's leave you with a grand vision. So forgive me, but this is my grand unified vision, that all building systems will work together and share information across an open control networking infrastructure, allowing any device, subsystem, or system or building to produce and consume data without the need for closed or proprietary components, and where all systems and applications reside in an open, integrated, secure, interoperable environment. Can I get a hallelujah? Hallelujah. All right, there we go. Well, we're taking steps. I've been at this now, almost 35 years or so in this industry. We've come a long way in 35 years, but I still think we got a long way to go. The next world that we're going to be living in, AI, enterprise systems, cloud-based systems, service as an industry support, lighting as a service, HVAC and refrigeration as a service. We're going to start virtualizing a tremendous amount of this. It all then comes back down to this core level of interoperability, effectiveness, and efficiency of the low-level devices and systems to working together. So the NLC Toolkit is a great step in this direction, thinking outside of our silos, which we all need to do. The HVAC industry has been very, very silo-focused since the beginning of my career, but we're starting to open that up by inviting others in. And there are other sessions here at both AHR and at the ASHRAE side that are talking about cross-overlap between other disciplines. We need to do that if we're going to get into this whole building and smarter building design. So with that, the toolkit information, if you missed it, if you didn't get one of the flyers, there's the link. You can click on that link or go to designlights.org and you'll be able to download the toolkit and learn more about that. And we certainly welcome your feedback. So we're looking for how effective this is. Are we on the right track? Is this something that you can see us expanding? Are there things that we're missing? Those are the things that we're looking for. And with that, I want to say thank you to all of our speakers and to all of you. Big round of applause to everybody.